Okay, so we are asked to we are given with a multi-plate clutch which transmits power of 40 kilowatts at RPM of 25 RPS. So the effective torque that I mean is supported to transmit the power, the effective torque which comes on the net torque that comes on the flywheel we can calculate from, that comes on the clutch you can calculate from the power and the speed. So that is all okay. Now let's consider a disk. This is how a single disk will look like. So R1 is the inner radius, R2 is the outer radius. It is given that R2 is 110 mm and that is 1.3 times of the inner radius. So inner radius will be 110 by 1.3, which is 84.615. Now the axial load, there are two things that is important in this clutch. The axial load that is supported is 2 pi into C into R2 minus R1. Now C is again something which depends on the maximum pressure into R1. Now remember that it's not a uniform pressure theory, it's a uniform wear theory. Okay, that's what the maximum intensity is given. Otherwise, the throughout the disc the pressure will be uniform. That is what happens for a new clutch. But generally, if a clutch is old, the outer surface gets eroded first, and therefore the more force will be concentrated at the inner surface, and that's what happens for a older clutch, and that's what we are assuming for this problem. So 2 pi Pmax into R1, the inner radius, by R2 minus R1. This is for the load, and the net torque which comes from, let's assume that the end is, so N into W into mu W into R mean. Now R mean is something that depends on whether it's uniform or uniform wear clutch, uniform pressure or uniform. So N is something which we need to find out. Mu is given as 0.12 and W is something which is again in terms of, so we are just writing that Pmax into R1 R2 minus R1, and R mean is, for uniform wear case, it's R1 plus R2, it's actual mean. So torque, well, the power is given, so power is torque into omega, and therefore the omega is 2 pi N by 60. So the torque, I can write power as T. The power is given as 40 into 10 power 3 kilowatts. Omega is 2 pi N, which is revolutions per second 40, and the torque I can just use this expression. So N is something which is unknown, and maximum intensity pressure is given as 0.15, and you have to use 0.15 because we are just using force units in Newton and length units in mm. So when you're using length units in mm, so that MPa will take care. So it's Newton per mm square is 1 MPa, right? So that will take place. You need not use 10 power 6, or otherwise convert everything in meters and use for MPa, use 10 power 6 Pascal. So that's the thing. And R2 minus R1 into R1 plus R2 will be R2 square minus R1 square. So 110 square minus 84.6 whole square by 2. So this, when you solve, and you will get it 10.63. So 11 is the answer. So two things, the formula for axial load and the formula for effective torque coming from the end disk. So that is the only thing which you need to know. So 11 is the answer. Thank you.